In the section on page 377 with compound inequalities, when you do these, remember that your ands are where they're both true. So this would be the overlap region. And if it's an or, it's if either is true. So they do not have to overlap. It's where either one of them is found. So on number 1, what I always do is I graph both. So here's 0 and here's 7. You don't need to number out anything else. Just have them in their relative positions. 0 is less than 7. So I'm going to have greater than or equal to 0, less than or equal to 7. Where do they overlap? They overlap between 0 and 7. So this is a trapped region. And so my inequality is going to be the x in the middle, 0 to 7. That's how you write that. Or as an and statement like this. So either one of those. Z is, so -2 and -4. So -4 is smaller than -2. So less than -2, greater than or equal to -4. So it's this trapped region, darkened dot there, open circle there. And so we put our x in the middle. It's less than or equal to -4 and less than -2. Notice on this, since this is an open circle, I use a less than there. And again, you can either have this or this. As you move on in algebra, this compact method would be the way that it's going to be written. Number 3, the first thing I'm going to do is flip-flop this. This is A is less than 5, and I want to see it like that so I can see my arrowheads. So I've got 5 and -6. So -6 is down here, 5 is up here. So I'm less than 5, greater than or equal to -6. So they overlap from here to here. So you can either have this as your solution or -6 to here. That's how you would write that. Notice these always face in this direction in this compound inequality. When I hit number 4, I hit an or, so it's where either one of them is. -1 to 4. So less than -1, greater than 4. And so this is your solution. With or statements, there's no way to combine them like this in an and statement. C is less than 2, greater than 3.5. So it is simply this, because it's where either one of them is. -3 and 1. So it's greater than or equal to 1, less than -3. And again, it's where either one of them is. So it's the or situation. Now, don't go into it thinking that it's always the or, because what if you had something and it was, let's go back to this one. What if it was, oops, and it was greater than -3? So that's this. Well, the answer then is not this or. The answer is just from here over, because this graph here would overlap that one and get it included. So the answer on that one is just y is greater than -3. So it's not with an or always just the original answer. I think in this section it is, because they're just trying to teach you that the or is where either one of them is true and the and is where they're only one, where they're both true. So we have 3 and 4 on this one, less than or equal to 4, greater than or equal to 3. The overlap region is right here between 3 and 4, so between 3 and 4. And that would also, could also be written like that. On this one, -5, it's less than or equal to that. greater than or equal to, greater than 0. So this is your solution. By the way, on an and, it's not always the overlap region. Sometimes there's no answer. Like if I had said x is less than 4 and x is greater than 5, here's 4, less than 4 is this way, here's 5, greater than 5 is this way. It cannot be both of those. This one has no solution. And then this one, again, I'm going to flip-flop my inequality so that my m is on the left side. So I've got -3 and +3. So m is less than 3 and greater than -3. So where they overlap is this region in between -3 and 3, but these are both open circles. So -3, 3. And notice my inequalities in this, written like this, always go in that direction. I don't include the or equal to because those are open circles. For 10, it asks you to explain why there are no solutions to x is greater than 2 and x is less than or equal to 2. Well, if you graph these, they just have 2 is the only number. Greater than 2 would be this way. Less than or equal to 2 would be this way. They have nothing in common. You say, well, they have the 2 in common. No, this one does not include the 2. There is no overlap or nothing in common between the two inequalities. So there is no solution to them.